Is it, if it is completed, type C. Mention these angles in your graph, all of you. And type C. If you type C, I will proceed. You have to mention this in your graph. If you have completed, type CM. Okay? Okay, then I am proceeding further. Okay? Now, let's go to next step. Now, we know the angle of departure at the complex poles. Now, we know that root locus will start from those complex poles. We know that root locus will start from this complex pole and it will follow the path of the asymptote. Means definitely the root locus will start like this and it has to bend to move along the path of the asymptote. Definitely. Okay. Along this angle it will come out and it has to bend and it has to follow the path of this asymptote. While following the path of asymptote, it has to pass through the imaginary axis. Means it will intersect the imaginary axis at certain point. Okay, on both sides, okay, at the root locus which is coming from P3 and root locus which is coming from P2, both will intersect the imaginary axis at certain point. Okay, that point is known as point of intersection, and we have to determine that point of intersection. Okay, so you have to find the crossing point on the imaginary axis. That point is known as point of intersection. So you have to determine the crossing point on the imaginary axis. Okay, so you know the characteristic equation, okay, of your given system. So this is already there in your notes. Where is it? Okay, so for the given system, you have determined the closed loop transfer function. Okay, so this is the characteristic equation, I think so. S into S square plus 4S plus 13. Is it? Yeah, S into S square plus 4S plus 13 plus K equal to 0. So there it was S into S square plus 4S plus 13. So yes, if you multiply it with that term which is in the bracket, it will become S cube plus 4S square plus 13S plus K equal to 0. So this characteristic equation is for closed loop system, not for the open loop expression which has been given in the question. Okay, that you must remember. Okay, so this is the characteristic equation. Okay, this is the characteristic equation for the closed loop system, that you remember. So this is the characteristic equation. Now replace S by J omega. Okay, replace S by J omega. All of you, I hope all of you start writing in your notes. Okay, replace S by J omega. If you replace S by J omega and you further simplify it, okay, you will get this expression. Okay, so you can see in that expression some terms are real, some terms are imaginary, isn't it? Some terms are real and some terms are imaginary. Two terms are real and two terms are imaginary. Equate the imaginary part to 0. Equate the imaginary part. What is the imaginary part here? Minus j omega cube and plus 13 j omega are the imaginary parts. Okay, so I have taken minus omega cube plus 13 omega and equated it to 0. No need to write that j value. Okay, so even if you write, doesn't matter, but no need to write. Equate the imaginary parts to 0. Okay, and simplify it further. Okay, simplify it further, you will get omega equal to plus or minus 3.6. Okay, you will get omega equal to plus or minus 3.6. It is the imaginary part, isn't it? Okay, of course I have not written j. If you want, you can also write j value. Albert. Hello. I'm sorry. Okay, equate the imaginary values. If you want to write j value here, it doesn't matter. So you will get some j omega equal to so and so. Okay. So omega value have got plus or minus 3.6. The crossing point of the root locus is plus or minus j 3.6. Okay. So since it's the imaginary part, you mentioned the j here. Since even though you have not considered j value, it doesn't matter. Okay, you can write the j value here. So okay, this is the crossing point of the root locus on the imaginary axis. Okay, so you have equated the imaginary part to 0 here. Now equate the real parts to 0. Real part is what? Minus omega square plus k equal to 0. Minus omega square plus k equal to 0. ఏం చేసావు వెరోనిక వెళ్ళి నుంచి hello. Now equate the real part to 0. You will get minus 4 omega square plus k equal to 0. You will get some value for k. This value of k at this means the value of k at this crossing point is 52. Okay, write on this slide. Write on this. So if you can see here, this is the k value at the crossing point. Okay, no need to write this whole theory part and all. I have written this for giving the explanation so that you can understand the concept. Okay, so equating the real part, you will get this. Equating the imaginary part, you have got some j of 3.6. Okay, now mention this plus j 3.6 and minus j 3.6 on the graph. Draw this sum, all of you. Point of intersection plus j 3.6 and minus j 3.6. I hope you are able to see it on the screen. Draw it. Mention those 2 points on the graph. Okay. So did you complete? If you have completed, okay, very good. So now you have the point of intersection. Okay, you have the asymptote, you have the angle of departure. So simply start from this pole, draw a curve passing through this point parallel to the asymptote. Okay, that's all. Next step I will show you. Okay, so this is your root locus. Draw it, Amma. It must start from this pole, pass through this intersection point parallel to the asymptote. Asymptotes, you can increase the length of these asymptotes. Okay, if you want, you can increase the length of these asymptotes. Okay, do it, Amma, all of you. This is the root locus. This is the root locus. Do it. See, Amma, if you have completed. If anybody has any doubt in this root locus problem, you can either type the message or you can unmute and talk to me. I will explain. Okay. Did you complete? Shall I change the slide? Type C if you have completed. Okay. I hope everybody has completed. Okay, I'm going to the next problem. Okay. So while taking attendance, I will see this graph in your notes. Okay. So next problem. Let us go to next problem. What is it? Yeah, this is your next problem, Amma. Open loop transfer function of a unity feedback system is given. Write down the problem. All of you write down this problem in your notes. Open loop transfer function of a unity feedback system is given by g of s is equal to k into s plus 9 by s into s square plus 4s plus 11. Okay, so this is the given open loop transfer function. You have to sketch the root locus for this system. So you can see you already know that poles can be obtained from the denominator of the given open loop transfer function and zeros can be obtained from the numerator. Okay, zeros can be obtained from the numerator. Okay, determine the poles and zeros for this given expression number. Step number 1. Write down the step number 1, all of you. Are you able to see the screen, all of you? What is the imaginary? Did anybody type the answer? I was not here. What is it? Is it plus J3 or J of 2.64? 64, huh? Are you able to see the screen? Did I present? Okay, I didn't present. Acha, acha. Okay, okay. I thought I was presenting. So, okay, now you can. I am presenting. Is it? I'm presenting. Okay. I have got some 2.64. Is this 2.64 correct or somebody got 3? Somebody has typed 3. So once again, recheck your answer and tell me this value, Amma, all of you. Somebody tell me. Poles, Amma, one is 0, another one is -2 plus or -3 or 2.64. Of course, 2.64 means approximately 3 only, but we want the exact value. We want the exact value. Please type it. Type it, Amma. $2.64. Okay. It is 2.64, Amma. Okay, 2 poles are. So there is a 0 here, Z1. Poles are 3. P1 is 0. P2 is. What is this? Why this I has entered in my previous problem also? There was an I after 2. Why is it? Okay, I might have copied and pasted. Okay, so P2, P3 and Z1. Z1 is -9, which you people have already mentioned it. Okay. Scale is 1 centimeter equal to 1 centimeter equal to 1 unit. I have already told you. Locate the poles and zeros on the graph. See exactly what I am showing. It should be in your notes. Okay. So you do it. If possible, you solve the problem. I have to take the attendance. I have to look into your notes also. So wait. I will take a screen.